I'll request Sharath to quickly introduce the topic first, network analytics, its importance, maybe briefly for about a couple of minutes, and then touch upon briefly about the hyperparameters which assist us or help us to improve or increase the effectiveness of the networking or the network analytics. Over to you, Sharath.
Thank you, Nitin. Yeah, you need to give some rest to your voice. I'll take it over. Good evening, everyone. Thank you and welcome back to the session. Thank you for showering your love continuously and learning things along with us and trying to upskill yourself for your careers is awesome. And while you do so, try to enjoy and also please do share your constructive feedback so that we can improve from what we are doing from this level to the next level. And let me jump into the today's topic. Today's topic, we will be discussing about network analytics. Like recommendation engine, network analytics itself is again a separate ocean in itself. And predominantly, we need to try and understand network with respect to interconnected entities. And whenever we talk about network analysis, we always talk about vertices and edges. And we also use network analytics in GIS. We also basically call the geospatial analytics. And in that, we have basically interconnected entities over physical objects. You can talk about Google Maps, for example, right? Open networks. Various other open source platforms where the maps are connected, right? All these things are based on network analysis. When we talk about network analytics, the first thing that you need to remember is network route optimization, right? It is widely applicable in transit analytics. It is widely applicable and so on and so forth. The most important library with respect to network analytics is Network-X in Python. Network-X is a package which will allow us to do a lot of manipulations on the complex networks that we basically have. Graphs, multi-graphs, various algorithms with respect to analyzing these graphs. You can also read the data from images, from XML data points, right? All these things basically are part of your analysis of networks. And let's jump into the topic. The networks basically allow us to give some weightage with respect to the nodes. And this weightage is directly proportional to the number of connections that these nodes contain. And it is heavily used in marketing area as well, marketing analytics. So let's not wait. Let's jump into the subject and try and learn more about what exactly is network analytics all about. Now, let me also ask Bharani to share his views with respect to network analytics. What are the important aspects that we need to look into this?
Sure, Sharath. Thank you so much. And hello, everyone, and welcome to the session. It's truly an honor to interact with you all virtually and share our experiences. If it is going to help you even to an extent of 1%, then we'll be extremely happy for the effort that we are investing in. Nitin, Sharath, and me putting in our efforts would mean a lot, right? Given our busy schedule, we are trying to pull off time just to ensure that we give you more knowledge, and the end goal is clear. You all need to get a job at the end of the day, right? Hence these interview preparation sessions, and these will go on. This would probably go on endlessly for, until infinity, I'm guessing. Okay. So network analytics is extremely helpful when it comes to analyzing graph data. Everything else, all the algorithms that we have discussed until now as part of our interview preparation session was all channeled towards analyzing cross-sectional data or tabular data which is in a nice structured manner in rows and columns. However, the moment we have graph data, our analysis changes significantly. Okay, let me also share my screen here. And these are a few things that I've put together so that it might help you. Let me also invoke my scribbling pen. So friends, these are a few Python libraries, and like Sharath has rightly told, NetworkX is extremely famous. And it supports different types of graph, undirected graph, directed graphs, multigraphs. Multigraphs mean within a network, you will have nodes and you'll also have connections, edges. This connection can exist when two people, A and B, are friends. You can also bring in another rule into this network analytics and say that also establish connection when two people are staying in the same community. So Nitin and I are friends, and Nitin and I also stay in the same community. So you'll have another connection like that. And Nitin and I are also colleagues. So you'll have another connection, yet another connection. So this is called as multigraph. When two nodes are connected based on different rules, you'll also have directed multigraphs, weighted graphs. For how many years were I and Nitin friends? If we were friends for more number of years, this particular edge will be thicker. If we are friends for only small duration, it'll be thinner. So, all these kind of graphs are supported by NetworkX. Alongside that, we also have iGraph, we have Graph Tool, we have Network IT, Network Kit, basically. And then Graph Wiz. All of these are used for constructing, measuring, and drawing complex networks. Networks of what? Communication system. Take any telecom company, telecom provider, or internet service provider. So what do you think will happen? There'll be a lot of cables. And you can say that from one point to another, one tower, telecom tower, another telecom tower, how are you going to establish the connection between these two? If there is a connection, you can, draw an edge like that. And think about huge number of, telecom towers, which we have, and the kind of connections that we have, either wired or wireless, doesn't matter, but, it's a network. Transportation systems. If you look at the railway system, you'll have a lot of trains traveling from one source to another, destination, from source to destination. And then if a vehicle is, traveling from one location to another, you put a connection. It could be rail network, it could be road network, it can be, airline network, so on and so forth, internet system, electric grid. Water systems, how are you supplying water? If a government department is supplying water from one location to another, then, all those things can be brought in. Okay, and then we also have, of course, networks will have nodes. You have to define what is a node. You then also have to define what is an edge. When do you establish that connection? And attributes. Attributes meaning, when do you establish this connection? What is a rational? Sorry, not just connection. What is the thickness of that, for instance? Like I've given you an example of Nitin and I. If we are friends for more number of years, that would be thicker. And then we also have biological networks like food items. If you look at hotel management, they extensively work on what food should be served with what other food, right? When you look at biology, then protein interactions. If you look at disease, how does it become an epidemic from one person to another when disease is getting transmitted? How? Right? Financial transactions, corporate partnerships, international trade, even in market basket analysis, social network, social media network, right? Some kind of cultural network. If you have religious scriptures, such as Mahabharata, for example, you have far too many characters, right? And then just to remember those characters is very difficult. And who is connected to whom? Who is on the side of Pandavas? Who is on the side of Kauravas, for instance? That's extremely difficult to read once and remember. So if you can represent that as a network, it becomes very easy, right, to remember. Yep. So this is what I had to get this discussion moving. Thank you.
Bharani, to add more points from where you left. There's this one specific point that I want to also show and talk about it. The network analytics is very prominent once it started, right? So of course, we call it as geospatial analytics also. The different name you can see. The one of the very good example is the US 2012 elections campaign. The results were completely against Barack Obama in those elections, and a lot of people were trying to predict who is winning. When the geospatial specific details were added, that is when the actual predictions came into picture. And right, only one person was able to showcase that Barack Obama is going to win that particular campaign. This was a very interesting example. You might also want to go through these details in the Wikipedia, which is available, friends. So all this while we were only looking at the previous historical data and then try to get the predictions done. But when the location specific details were added, that is when the actual explanation of the true winner was able to explain. The model was able to explain only then. So this is another very good example that you might want to understand. And when I talk about the applications, right? Bharani rightly said, the analytics is applied in various domains, right? So these are very important areas where you can talk about how these network analytics can be implemented. And I also want to add one more very important point we generally talk about is the community detection. There are algorithms which are specifically used for community detections. Extremely helpful in tapping the terrorist organization related activities, or trying to capture the fraudsters in telecommunication industry specifically, or even for that matter, the banking sector is using this particular strategy to capture the defaulters. This is based on a very simple logic. I'll try to explain this. Let's say we have this person who has taken a loan. Okay, customer who has taken a loan, and this person is defaulting now. Now we do have the credentials, the person's details like their address, phone numbers, and all those things. But if the customer is deciding to default, obviously he will move on from those details, right? So the phone number will be changed, the address will be changed. So we'll not be able to catch hold of that particular person. Now, how do we actually try and identify this particular this individual, and how do we catch hold of that person to retrieve the loan amount? So the idea is try and look at historical data of the, let's say, the phone number that we have, right? So connect with the telecommunication industry identify what is the outgoing calls that this person was making using that previous phone number. So we will get the details, right? These are the various numbers that the person was frequently connecting to, like probably his wife, his family members, his close friends, office, etc., etc. Now, once this person has switched off the phone number, removed the SIM, we will not be able to catch hold of that person. So how do I get this particular person? So what we do is we will try and capture the incoming calls for these phone numbers and then try to see if you have any SIM from which the calls are going to this particular number, the numbers, right? So if the person who is the fraudster is changing the number, doesn't mean that all the people who that person is trying to connect will also change, right? So these numbers will be consistent. So if we can draw this kind of a mapping, then we will be able to identify the similarity here, right, in the networks. I mean, this is also a network connections. So using this information, we will be able to track and identify who that particular individual is who is using this particular SIM. And this way we can try and catch hold of that fraudster. This is one of the very interesting application of network analytics, and this is also called as community detection, logic. Community detection algorithms are there. There are fast greedy algorithms, leading eigenvectors, and right edge betweenness algorithms. Network analytics is, as I explained, is itself a very big subject, and one of the very important question or point that we need to remember is it is compute heavy. Computationally, it becomes very heavy, and we have the Spark programming language, right? It's a framework, Spark framework, which works on distributed environment, cluster of computers to work with network related data, right? And network analytics to be performed. Spark has a specific capacity or a module or a feature you can call, which is called as GraphX, which is only decided or developed to work on network data frames. Just because it is computationally very heavy as we are dealing with a graph, right? And when we decode the graph, you will have this graph as a function of nodes and connections, or we also call them as vertices and edges. These are alternative names to the entities. So if I talk about social media network, individuals become the nodes or vertices, and the connections between them are nothing but edges. These are the names that we use, the terminologies that we use. And network analytics is all about trying to break through this data, decode this data, and try and measure the value for each node based on the characteristics with respect to the number of connections that edge has, right? That node has. So we are decoding, right? We are going to the ground level and then try to understand what is the value of each node. That in turn helps us to understand what is the complete value of the entire network. Which group is more powerful or has more value? Now, this is one of the very interesting and important topic. And to all my students, right, I ask them to very closely keep updating your LinkedIn profile and build your network so that you also get good value. And when your interviewer is looking at your LinkedIn profile, they will get a very good impression if you have all the connections pointing to either data scientists or data analysts or organizations which deal with these machine learning related activities. So it gives you a value, right? So that is very, very important. So this is some insights from my side for network analytics.
Thank you so much, Sharat and Bharani.